Good evening, everyone. Thanks for joining live interaction session 2 for the Learning Analytics Tools course. Before I start this live interaction, I would like to thank everyone for actively interacting in the discussion forum. Also, thanks all of you for responding to others' queries. The purpose of discussion forum is to learn from peers and ask questions, and it's interesting to see it's happening. And thanks for that. Then I would also want to apologize for a couple of mistakes we did in the assignment. In assignment 5, we had our server ready for ISAT. Somehow, due to certificates issues within IIT, we have to migrate our department server to the institute server. While migrating, we were not able to actually, we're not able to actually move all the content. So we are still in the process. That's why we have to, readjust the assignment file. And in assignment 8, we had a mistake. It's because we had to change the question. Initially, we had a question a bit difficult, but we wanted to reduce it to, bit the level where we would expect you to work on. When we changed the question, we forgot to change the options. So that was a mistake. But be assured that we check the questions thoroughly before post. And there was a question in the discussion forum also, what happens if this happens in the proctored exams? In proctored exams in general, we check the marks. And if you see, a lot of people have trouble in some of the questions, some due to some misambiguation in the questions or something like that. We have an option to add up the marks for everybody in the class, or we just readjust it. Those options always happens, in the NPTEL exam. So be rest assured that we did test it, and we considered it before we post on, creating the questions. So before we go into taking questions from the Excel sheets, also in the live interaction, I would like to clarify a couple of things about sequential pattern mining and something related to regressions. So I will go for that discussion. After discussing that, I will take the questions from the Excel sheets, which you already asked. And if there are any questions you are posting in the live interaction, we would like to, we'll go and answer it. So let me share the screen. Okay. First one I want to talk about is the SPM. So in a sequential pattern mining, I think we all suggested, and we all watched the video about SPM a couple of weeks ago. In a sequential pattern mining, just compared to the other simple association rule mining, the only condition is that maintain the order of sequence. If somebody read and watched the video after reading, after watching video, if they go for a quiz, suppose somebody's read, then watch the video, then after watching video, if the student is taking quiz, we might consider this action sequence like a read to video is the one of the pattern. But we will not consider the reverse, that video to read, unless it occurs. In association rule mining, we doesn't care about the sequence of appearances. We just simply say with whether any two actions, whether it appears in the first or in the last, whether these actions appear together in the particular student or not. In a sequence mining, we want to maintain the sequence. That's a very simple distance. Now I want to talk about this SPM in detail actually. So the first thing is consider there's a pattern called read to video. Similarly, there are many patterns. Let's consider read to video, and quiz is the one, the queue, and video, and simulation is yes. Something like a forum. Okay, we have now 5 set of actions. Read, video, quiz, and forum. So what we usually do, we first identify the patterns. Consider we have a different pattern: simulation to forum, video to quiz, and read to forum, some kind of patterns we have. Consider we are looking for these patterns for 3 students, S1, S2, let's say 4 students, because 3 we already used in the slides. Let's say we are using it for 4 students. So, and the read to video particular pattern appeared for student 1 for say 2 times, it didn't appear for this student, it didn't appear for this student, but this student got 7 times. 1, 1, 3, 1. 1, 0, 8, 8, and 13, and maybe 0, 14, 2, 3. Okay, why I'm writing a different numbers here is I want to make avoid the misconception of what exactly we do. The thing is, first step is number of students. Okay, first step is what's the total count of this particular pattern occurred for all students? That will be 2 plus 7, that will be 9. And for this pattern, the number of times the pattern occurred. Just writing it. Let me write it clearly. Okay. So it's number of times the pattern occurred. So I'm simply adding number of times this particular pattern occurred. It will be like a 6, 21, 22, 16 plus 19. So this is simply the number of times this pattern occurred. But how many students this pattern got it? Like how many? This is like a total frequency, not the frequency. How many students got this pattern? How many students got this pattern support? So number of students, basically yes support value. The 2 student got it. The total number of student is total number of n is 4 because S1, S2, S4, the 4 students. 2 students out of 4 students got it, support is 0.5. Here 4 students got it, so 4 out of 4, 1. Like 3 students got it, it will be 0.66. 3 students got it. Oh, sorry, 0.75. Thanks. Yeah, I'm still thinking in the 3 students. Okay, so this is the S support. S support tells you that how many students really got this particular pattern. So 0.5, 0.75, 1 or 0.75, 0.5. So now we can say that there are 100 students in my class. I don't want to consider if the pattern occurred only to say 40 students. I want to consider patterns which occurred only if the pattern occurred at least for more than 80% of students in my class. Then 0.8 I can consider the filter. I can remove all of the patterns. I can talk about, work on those patterns. So now the patterns are S support is there. So what is high frequency mean? This is the someone makes a mistake that they take this number of times the pattern occur. There are 4 there. It's not 4. We want to know how many times this pattern average time occurred for these 2 users who got the pattern, which means so S support is very important here to find it. So high frequency mean is calculated for the number of students who got the pattern. So that is 7 by 2 is 3.5. So this is 6 by 4, it is 1.5. Oh, 9, sorry, 9 by 2. Thanks. Thank you. So it's 9 by 2, and this is 22 by 3 students who got it. This will be 7.33. And this is 19 divided by again 3, this will be 6.33. So this is the high frequency mean. And now this is clear, right? For example, when you compute the sequential pattern mining, you find out number of times this particular pattern occurred and number of students who got it, that is a mean value. But the story of mean is wrong. For example, this particular case, the student got 14 times and other students got only 2 or 3 times, but you will say average is 6.6 times. It is not true, right? We hope that if I have 100 students or 80 students, this will be a normally distributed. Only one student would have spike, it's fine. But if you think the standard deviation, when you compute the mean, also try to compute the standard deviation. When you see the standard deviation is really high compared to the mean values, or it's like more than 4 or 5 or 6 or something, go ahead and change mean to median. Use the median value. If I use the median will be 3, not 6.33, right? 2, 3, 14, the median will be 3. So this is about SPM. I hope it is clear. Before in a slide, due to the examples I was selected, I always having number of students and the pattern circles always equal. So it is not clear whether we should divide the total number of patterns with number of total number of students or the students who only got this pattern. So that was not clear. So I just wanted to be clear this. So let me go for the next one. Now, the other question I want to answer before we go to the slides is, it is about regression. I think we are not clear the regression also maybe in the slide. So the one is, let's talk about linear regression only. We talked about it. If there are, for example, if there's a x and y is depend on the x, and there's some equation. So this is equal to y is equal to mx plus 6c. So the m is the slope and c is the intercept this way. Right. So this is very trivial, right? So now if I want to change this equation to, I want to change this equation to the linear regression equation. What I do is y is equal to w1 dx x1 plus some, it can be b, it can be some value, some intercept value, or I or something like that. So we can call this a w1 or theta1 or theta0, something like that. Okay, so this is some intercept value we can consider. So this equation is simple equation because we have only one independent variable and one dependent variable. This is a simple linear equation. Suppose I have another value instead of x. This is maybe attendance. This is maybe the performance in final exam. Suppose I have another variable, for example, another variable of if I have another variable of x2, say the assignment submitted or assignment marks. Okay, if I have another variable, now I have my equation will change. Y is equal to w1 x1 w2 x2 plus some intercept. It can be c or b, whatever it is. I don't know. There can be any number. The b, c, 0, theta. It's up to you. Not 0, p or c or a, anything. Now the idea is that I have to find, after giving the lot of trained data, I have to find the value for w and w2. So this will not be the linear equation. Instead, this will be some plane. Actually, it's in the 3 dimension will be like looks like a plane. So now the idea is we need to identify. There are two ways to identify from historical data. So we can use the data to predict the y1. This is a multivariable linear equation. That's not a single variable. It's a multivariable. The variable is true. There's something else where instead of predicting the y, only one y, that is a mark. If I want to predict multiple things, mark plus something else about the student. If I have y1 and y2, that is called multivariate. So I just want to clear this. Actually, the thing is missed in the class. So this two things, I think you know when you are watching the video, please consider these two things also. Like in a linear regression, you should have consider multivariate, multiple variable, and in SPM, computing life frequency mean is based on number of students who got that particular pattern, not all the students. That's the division you have to do. Okay, I hope you are reading that, and you are when any questions there, you can ask questions in the discussion forum. the TS will be there to answer all your queries, or I see that others friends are actually also answering the questions. There's one more thing. We also going to add a videos about data pre-processing because we thought the 2 weeks course it would be too much to add everything. But data pre-processing is really an important point when you are trying to use this data and use this course to look for a job in a data science kind of career. Data pre-processing is very key, key function. So I would suggest we will be posting additional videos of the data pre-processing in a couple of weeks. Please check that and please watch the video also. Now let's go back to the questions. So now let's going back to the questions in the slides. The first question is about career. What is a career opportunity after we do the learning analytics course? So it's the course basically. If you are a teacher, I would be suggesting apply it in your classroom because you have some passion towards teaching. So that's why you are there. Try to improve your teaching method so students can learn better. If you are looking for a job using this, there are multiple careers. Basically, we are teaching analytics by using the educational data set. That's it. If the data set is not education, if it is finance, or if it is about healthcare, or if it is about some production or logistics, all you have to do is understand the domain knowledge. Because in education, when we create the features, since we know the domain very well about how students learn, when you compare the sequential pattern mining, we know what each pattern means. Suppose somebody is reading for multiple times in a short reads and spending a lot of time in the, for the long read, we know the student is skimming about multiple topics and selecting one particular topic. We can make inferences from those. But in other domains, please understand what domain is actually we want to look at it and learn the domain better so that you can extract the features well and apply the ML. The whole goal of this course is that given any scenario, it can be the classroom environment or the computer-based learning environment or any other environment, you should be able to collect data. From the data, you should be able to come up with a nice set of features, features like average session time, something like that, based on the frequency and duration. After identifying the features, you should be able to do the descriptive analytics, that is use some visualization. You can use some software tools like Tableau, Power BI, or Data Studio. Then do some prediction. That much is enough for the data science, and that is what exactly is expected. While doing the prediction, please know what are the ML methods and what are we looking at, and also when you look at the metric, you should make proper inference out of this. These are the basic things you have to consider when you are looking for data science career. So domain is just learning analytics, but can be useful for the other areas and also. If you are interested in learning domain, look for the companies. There are a lot of companies. For example, the foundations started run by the lot of corporates. Tata Foundation and the different big banks. They have a foundation. They have their CSR fund. Most of the corporates in India spend the CSR fund on education mostly. So look for those companies, and all of these, the foundation's company needs someone to look at the data and provide some valid analytics. So there are a lot of opportunities there, and that is the one place. Or the big corporates who are in edtech space, they also be looking for analytics position. But if you're applying when you have a domain knowledge and you have clear knowledge about education space, it's easy to get a job there compared to others. So that's the only thing I can think of about career opportunities. That's one. Let's move on to the questions in the Excel sheet. Second question in Excel sheet is about correlation and regression. See, this is very clear. I think we when we discussed about Pearson correlation, right? We showed that even the correlation value can be 1, but the slope can be still very slow. As long as if when X and Y has a linear correlation, the slope of the correlation is not measured in the correlation. Slope of this relationship is not measured. The slope tells how strong the Y depends. For example, if X increases by 2, the Y will depend increase by 4 or 5. The strongness will be there. the strength, the multiple factor is not come out of the the Pearson correlation, but it says how both are correlated. If X occurs, Y also occurs. If X increases, Y also will increase. Only these values can be identified in the Pearson correlation. And we also saw Pearson or Spearman correlations. It's never consider correlation as the causation, and correlation, whenever you do try to plot the data and find out whether this makes any sense, because if it's non-linear, the correlation will not work. So correlation has its own limitations. Whereas in regression, it's very important. For example, there are a lot of work is happening in this field of understanding regression equation for the explainable AI. It's very interesting is that if I control, suppose the regression equation have x1, x2, x3, three weights for three variables, and there's a y. If I control x1 and x2, which means I will not change the values of x1 and x2, okay. If I keep them as a constant, if I change only the values of x3, the weight is directly impacts the y value. So if I increase the x3 by say 2 to 3, whatever the weight, it will be the multiple will be added to the y1. So in regression, if there are multiple variable regressions, multiple equations, that if you control all other variables, all other the weights constant, fixed, and the rate of change of y is based on the weight of the one we are changing. That is how they are actually. That is the beauty of regression equation. So regression equation can tell more about each feature's impact on the y, that is a dependent variable. Whereas correlation is a bit different. Correlation tells it can be 1 even the slope is low. So if you're looking at if there the relationship between x and y is exist, and there's a linear relationship, if x increases, y increases, it will be 1. 0.6 means less relationship. And if it is less than 0.2, it will be like no relationship or something like that. It's kind of a random thing. That's all you have to consider versus correlation versus regressions. Okay, I think that's the two questions we covered. And do you have any other questions in the chat? No. Okay, I think thanks. Since there's no questions, and I think we are doing very good in terms of questions and answers in the discussion forum. Is our TA Anthony. Anthony would be replying most of your queries. Actually, you would have not seen him. But he's the one who is actually replying to this queries, and setting up the questions for assignments and all. Yeah, this is Anthony.
Solutions.
Oh yeah, solutions. Yes, Anthony is actually posting the solutions for every week, so that you get a clear idea. So yeah. So if you have any questions, please feel free to ask in the discussion forums, or we can meet in next live interaction sections. Okay. Is there anything else? No. Just a minute. Just a minute. Okay, I think there's no questions. Thanks. I think we can stop the streaming. No. I'm asking to. Yeah, yeah. I will end the stream. Just simply switch off the. Can you do it? This is it.
Yeah.